Good morning, my dear students. In the previous video presentation on integration, we have done problems up to exercise 7.5 from the NCERT textbook. Before doing the sums from the next exercise, we'll do a simple proof which goes like this. See here, d by dx of uv is equal to u dv by dx plus v du by dx. Everybody knows this rule. This is called product rule of differentiation. Here we can very well write this as d of uv is equal to u dv plus v du. U, v are functions of x. In the previous step it is called differentiation. Here we call it as differential coefficient. Now let me take integral on both sides. Integral d of uv is equal to integral u dv plus integral v du. Now differentiate and integrate a function, or integrate and differentiate a function. It will give you the same function. Therefore in LHS it gets reduced to uv. uv is equal to integral u dv plus integral v du. Therefore we ultimately get the formula integral u dv is equal to uv minus integral v du. Let me just repeat the whole process. You know very well d by dx of uv is equal to u dv by dx plus v du by dx, and uv are functions of x. Now what I will do here is, this is called differentiation. Without dx in the denominator, if you write, we call it as differential coefficient. Therefore d of uv here is u dv plus v du. Take integral on both sides. Integral d of uv is equal to integral u dv plus integral v du. LHS gets reduced to simply uv. uv is equal to integral u dv plus integral v du. Therefore ultimately I get the formula integral u dv is equal to uv minus integral v du. This is called integration by parts. This formula is called integration by parts. I am taking into two parts and proceeding. One part is u, one function is u, other is v, and proceeding. Now for it's called integration by parts. Its application we'll do in some problems in the from the next exercise. The first sum in exercise 7.6, it goes like this. That is, evaluate, this is the first problem. Evaluate integral x sin x dx. Listen carefully. You know very well derivative of cos x is minus sin x. Therefore let me just multiply two minus signs. I need it, therefore I do. Just listen carefully. Now this minus sin x dx can be written as d of cos x. Just listen carefully. d of cos x is minus sin x. d of means I have to multiply dx. That's the meaning. If you want, you can write the reason. Since d by dx of cos x is minus sin x, just multiply dx to the other side. You will get minus sin x dx as d of cos x. Apply the rule integration by parts. Minus x cos x minus of minus plus integral cos x dx. Since recall the rule, since integral u dv is equal to uv minus integral v du. Here in fact I have u to be x and v to be cos x anyway. V to be is equal to cos x anyway. Now let me just simplify further. This will get reduced to minus x cos x. Integral cos x is nothing but plus sin x plus c is the constant of integration I used to add normally. Let me repeat the whole process. Integral x sin x dx is a question given to you. Let me just underline. This is the question given to you. Now I'll multiply two minus signs over here. One minus sign outside, one minus sign inside. This minus sin x dx can be written as d of cos x. See here, d by dx of cos x is minus sin x. Therefore, cross multiply dx minus sin x dx can be written as d of cos x. Now, for my x happens to be automatically, my u happens to be x, sorry, and my v happens to be cos x. See here, this is the form u dv. Therefore, apply the formula uv minus integral v du. Minus sign is already there outside. Therefore, it gets reduced to minus x cos x. Minus into minus will become plus integral cos x dx. Now, the final answer will be minus x cos x plus sin x. Integral cos x is sin x plus c. This is not at all difficult to follow. Understand, it will be always easier. Let me move on to the second problem now. Let me just move on to the second problem. Second problem goes like this. You mean to say evaluate integral x sin 3x dx. Remember carefully, derivative of cos 3x is minus 3 sin 3x. Therefore, multiply and divide by minus 3 in the next step. Minus 3 sin 3x dx. Now, listen carefully. I mean to say this will become minus 1 by 3 integral x into d of cos 3x. Derivative of cos 3x is minus 3 sin 3x. Cross multiplication of dx will give you the answer automatically over here. Now apply integration by parts. This will become minus x by 3 cos 3x minus into minus plus 1 by 3 integral it will be cos 3x dx. It will be cos 3x dx. Therefore, I mean to say automatically, you can write the reason if you want. Since integral u dv is equal to uv minus integral v du. Here, u is equal to anyway x. V happens to be cos 3x. Recall what is my u, what is my v here ultimately. What is my u, what is my v ultimately. Therefore, this gets reduced to automatically minus x by 3 cos 3x plus sin 3x divided by 3 into 3 becomes 9 plus c is the constant of integration I used to add normally. Let me just repeat the whole process. Integral x sin 3x dx, that is a question to be found out. Now multiply and divide by minus 3 in the second step. I am just underlining for your purpose. Minus 3 sin 3x can be written as d of cos 3x. If you want, you can write in bracket here d by dx of cos 3x is simply minus 3 sin 3x. Just cross multiply dx. I'll get automatically d of cos 3x as minus 3 sin 3x dx. Now instead of u I have x, instead of v I have cos 3x here. Now for apply the formula uv minus integral v du, formula which we derived only in this particular video anyway. Minus 1 by 3 is anyway there, multiply that. I'll get it to be minus x by 3 cos 3x minus x by 3 cos 3x minus of minus plus 1 by 3 integral cos 3x dx minus x by 3 cos 3x I have. Okay, then of course I mean to say cos 3x integral cos 3x sin 3x by 3 in derivative I have into 3 in integral I have to divide by 3 so that 3 gets cancelled. Already one 3 is there, therefore 3 into 3 gets reduced to 9. That is the final answer anyway. I hope it is very useful for you. You are able to follow, I am sure. Share it with your friends. Rest I'll continue in the next video. Thank you students for patient watching.